Application programming interfaces, or APIs, define the requests or calls that software programs can make between each other, along with the instructions for how they are made, what they return, and in what format. Joshua Block, in his talk, A Brief Opinionated History of the API, traces the history of APIs all the way back to Herman Goldstein's and John von Neumann's Planning and Coding of Problems for an Electronic Computing Instrument, Part 2, Volume 3 in 1948, where they introduced the term subroutine libraries, a programming methodology for a stored program computer. The idea that programs will make use of common operations and that library subroutines would reduce the amount of new code, and therefore the errors introduced with new code, is foundational to how we build software. And this grew into what became the first APIs. Fast forwarding to today, APIs exist for nearly any and every piece of software and hardware we encounter. APIs connect together the programs and digital tools to expand and extend the built-in functionality of these programs. And as we build applications on the Ethereum blockchain, APIs continue to play a role in connecting and extending the functionality of the programs that we call smart contracts. Welcome, I'm Tom Hay from ConsenSys Academy and the ConsenSys Developer Relations team, and I'm happy to have two fantastic developer relations leads joining me today, Sean Brennan from Infura and Adam Bavosa from Compound. In this webinar, we will review the concepts and code required to build your own API, specifically to invoke Compound smart contracts using conventional HTTP requests, with Infura as a bridge between the Ethereum network and your application. I'll turn it over to Sean Brennan to give you some more background.
Hi, everyone. My name is Sean Brennan. I'm going to start. Let me screen share right now. Thank you, Tom. All right. Again, yeah, welcome to the third ConsenSys live stream. I've got some lightning topics on topics that are related to having a smart contract API. They're going to go just briefly into some things you should know about them, the Web3 connections necessary for them, as well as how to do real-time updates on your site. Again, I'm Sean Brennan, the developer relations lead at Infura. These are some social. Again, I invite you to register for Infura for free at infura.io/register, and we have an active community site for any questions you have, and love to see a discussion of any of this on Twitter. So what is a smart contract API? Smart contracts are things on the Ethereum network or others that are code written in a specific type of language, usually Solidity, where you need to interact with them, you need a Web3 connection, which can be Infura, or you can run a local node like Ganache or Geth or Parity, these types of local nodes that are a connection to the Ethereum network, or you can use Infura, which is a bit easier. So Ethereum contracts have a specific way to call their methods, and Ethereum methods are restrictive in how complex they can be. They have to run on every computer in the Ethereum network at the same time, and so there's some memory restrictions. You might want to combine those methods in different ways or run some processing on top of it, and so you can actually create your own layer on top of Ethereum where you write the connections into those Ethereum contracts in your own preferred way. And so we'll go more into that later. But first, I want to get into the Web3 connection and show you an example of basically how powerful that can be. So on Web3 front ends, there's a couple different parts of things. We'll focus on the Web3 connection and then go into the JavaScript code necessary. So something like Node.js, Express. All these take a Web3 library to get the Web3 connection. So in basically any preferred language you have, you can use any of these languages here, among others, to connect to Infura or connect to a local node and get that access to the Ethereum network in a much nicer way than you might So the original way of doing it is like sending raw transactions, the Infura curl. These libraries basically make it much easier for you to interact with the Ethereum network, and is very much recommended. So like the very basic way to connect to Web3 through Infura would be to curl your network, and you'd hit this web request, and you might send like any Ethereum method you want. You can either read the blockchain, like get the latest block number, or you can send a raw transaction, which would cause some effect on the Ethereum network. A better way to do it is to use the Web3 library, which you put in your Infura URL, and then, for example, for the DAI contract, you just create this contract, use the contract helper method to put in the address and the ABI, and from there you have an object which basically represents the DAI contract on Ethereum, and you can interact with that without having to curl every transaction, and there's better ways of reading data from the blockchain. And so here's an example of what that looks like in practice. There's the Web3 is requiring the Web3 library. Then this second call uses the Infura connection to what's called a provider. So it creates a Web3 provider using your connection to Infura. And from there, you can call different methods on it. For example, the get balance of a certain address. This will return the Ether balance of that account or contract. And this is just a fairly simple Node.js code that will return that result in Ether. So here, switching gears a little bit. So this is great. You can run this on the back end or in the front end. But one issue is that, say this balance updates over time. Say there's changes to the balance, or you get a new user that signs up and you want that balance instantly. There's different libraries for that as well. Ones that I really recommend are Embark's Subspace library or Truffle's Drizzle library. Probably will loop back to this at the end and have a discussion about how this could work with the Compound API. But basically, this tracks different events that you care about. Basically, for Compound or pretty much any contract, you have certain events that you care about, certain data, and you want either your backend or your front end to react to those data, react to those events exactly as they change. So you can either update the user as someone's balance updates or a transaction goes through, or on the back end, your system might be reliant on just a flow of different processes, and with each bottlenecked by the one before it, you care about being as real time as possible. And so these libraries are useful for that. As a quick example, if we want to track the DAI to ETH trades on Uniswap, this is their front end. So their front end uses this as well. But say we care about something specific, we just want to track the DAI and ETH trades. We can use the Subspace library that I talked about. It's really just about 100 lines of code. I go into it in detail in this blog post here. You can search Infura blog, and it's one of the recent ones. So basically uses, as I said, it creates the DAI contract variable it uses Web3 under the hood. And from there, it sets it gets the last 5 DAI ETH trades. I'm going to quickly go through this because it goes into detail in the blog post, but basically it gets the token sold, and from there, on the right side is basically the data block that is available with Subspace, and from there you can put it into your front end and track the last 5 trades, and it's actually surprisingly simple with the amount of lines of code necessary to do it. And so basically what I want to highlight is that using Infura and using, say, Solidity is is great, but there's different really useful libraries to let you build something really, really cool quickly on top of it. And so if you're building a smart contract API, I want to stress that these are important to know about and very useful. So here's some more code for that. And what we'll get into, what I know Adam's going to get into and we'll discuss later, is how to basically put this, say you care about the Uniswap trades or the MakerDAO contract. So they have specific methods that are tracking those. Basically, you can track those contract events and you can create methods for interacting with those contracts that are on the blockchain. But you can create custom methods. Say you care about the last 5 trades, and so you can create your own specific last 5 method. And really you can get creative in what you can basically build another layer on top of the Ethereum smart contracts with the backend side of things, creating basically the Node.js code, and then these libraries like Web3.js, Ethers.js, and in like Subspace, as I mentioned, all of these let you basically save time and create something really cool, either in the backend side of things and the code logic, or on the front end side of things where you want to display something to the users. And yeah, so that's my quick survey of some pieces that you should know about before Adam's talk. And so again, yeah, register for Infura. It's free and it's really simple to use. We're available to answer any questions on the community site, and I'll be in the chat, and looking forward to hearing about how to build with Compound. Thank you. Adam, if you want to take over the screen share.
Thanks, Sean. That was great intro. A lot of great topics there that are really great for developers to get going with Ethereum. So I got a little slide deck for you all. I'm Adam, and I'm the developer relations lead at Compound, and I'm going to show you some ways to make an Ethereum API that invokes Compound smart contracts. So here's some methods which you could reach me. I am on Twitter, also Discord. You can come to compound.finance/Discord to join our Discord. And we got a development channel where you can ask your questions, and there are lots of experienced devs there to help you out with your code. And you can always email me as well, adam@compound.finance. I'm here to help you out with your Ethereum projects, get you going. So here's what I'm going to talk about today. I'm going to tell you what the Compound protocol is in case you are not familiar, and why you would build a REST API on top of Ethereum. And I'm going to go through the code required to build one, pretty basic Node.js code, simple JavaScript if you're not familiar. And I'll also show the resources you can use to get started on your own, where you can get help, where you can see documentation, stuff like that. So Compound is a autonomous interest rate protocol built on Ethereum. So people can supply their Ethereum-based assets like Ether or DAI, and you can supply them and earn a varying interest rate. So when assets are in the protocol, they earn interest, and the interest rate varies based on supply, demand, economic model, that sort of thing. And the inverse of supplying assets to the protocol is that you can also borrow assets. So say you have lots of Ether, but you want to use USDC to pay for something, you can supply Ether as collateral, and you can borrow USDC or another asset that the protocol supports and use that for whatever you'd like. So the interest that suppliers get, it comes from borrowers paying interest for the borrows they've opened. So the protocol is written on Ethereum, so it currently only supports Ethereum-based assets, and I'll show you the assets that we currently have working in the protocol. Of course, ETH. There's also DAI stablecoin, USDC. Just recently added Tether via community governance. And we have Wrap Bitcoin, 0x, Base Attention Token, and Augur, which is going to get updated real soon. Cool. So that's a little bit about Compound. You can just basically supply and borrow Ethereum assets. And I'm going to talk about the REST API component that I'm going to go through in this workshop. So you can use the Compound protocol with by directly accessing it with Web3, like Sean talked about. And you can also do something like a REST API on top. So a REST API is something that's a little bit older. They've been around much longer than Ethereum, and they're much more widespread through development around the world. Developers will know how to use a REST API more often than they'll know how to use Ethereum. That's just because Ethereum is so new. But what we can do when we create a REST API that does the Ethereum interactions for us, we can increase the consumer audience of those smart contracts. So when we have a REST API available, developers don't need to learn how to do all the Web3 stuff necessarily. So it sort of makes this API opens up the audience, makes it larger for your smart contracts and whatever your product is on Ethereum. So yeah, we also get the benefit of the consumers of the API don't need to know Web3 necessarily. And we also get the ability to have lightweight integrations. So if you wanted to use, say, a Web3 library like Sean showed, like Web3.js or Ethers, those libraries are quite large and they have dependencies. But for REST APIs, most languages have an HTTP library built in. So it's pretty lightweight to be able to do things like get, post. Those kind of requests are simple to write code for in pretty much every programming language. So you can have a lightweight integration with a REST API compared to using Web3 directly, because Web3 libraries are fairly new. They're not in every single language. They are still being made very available. So we got the benefit of lightweight integrations, and also creating a REST API is optimal when you manage customer keys, meaning the Ethereum private keys. This way you can do the writing operations of Ethereum easily using the customer keys. So say you have a business where you manage keys for the customer. They never see the keys to sort of take away that complexity. This REST API will be beneficial for your business. So here are the methods that we'll be able to use with our Compound Protocol API. You can get your Ethereum wallet's ETH balance, get your cETH balance, get your balance of underlying ETH in the protocol. You can supply ETH to the protocol, and you can also redeem ETH using cETH. So something I didn't mention earlier is when you supply assets to the protocol, you get a C token in return. So there's C tokens for each of the assets that I showed earlier. So you would call the mint function on the C token contract, and that sends your asset to the protocol, and you get minted C tokens in return. And the C tokens can be redeemed for the underlying asset at a later date. And of course, if you're supplying the exchange rate from C token to underlying increases over time, so you actually get more underlying for your C tokens as time goes on. So I'm going to show you how to do that with Web3.js inside of the API and make super simple REST endpoints for consumers to sort of abstract away the complexity. So these are the technologies I'm going to use. Of course, Infura, which will be my access point to Ethereum, and Node.js, JavaScript. Our API is going to be totally Node.js, and mostly using a framework called Express, which is like a web server framework, very lightweight, very popular in Node.js community. Web3.js will be my library for making those Web3 calls. Of course, you could use other ones if you'd like. I chose Web3 because it's one that I know. And also I'm going to be using curl to demonstrate the usability of the API. So curl is just a command line tool for making HTTP requests. So these are the resources for my workshop. If you want to dig in yourself, you can check out these resources to learn, to check out docs, just anything to get you going. Compound Finance website has documentation of all of our smart contracts. You can join us on Discord in the development channel to ask questions or just talk about ideas. Lots of friendly people there to help you out. On our blog, we have a blog post particularly how to walk through this workshop. So you can find that there if you want to go step by step. And also I've got some guides for learning how to use the protocol and also Ethereum in general. GitHub, I got the repository for this code that I'm going to show you. That one's got the nice big star there. And yeah, you can clone it yourself and get going. So that is what I got. And now I'm going to go through the workshop for building your own Ethereum API. So if you head over to the Compound Finance website, compound.finance, you can go over to docs. And here's where we got our guides for getting started. Each of our contract addresses on each of the networks. We got mainnet, all the test nets. And we got some math guides there. And of course, C token contracts, we can do stuff like mint and redeem. We got examples in Solidity and also Web3. So I'm going to head over to my repository for the guide I wrote, which is here. And I'm going to clone it. So I'm going to do copy that Git URL. I'm going to come over to my command line and I'm going to clone. I'm going to go git clone and paste that URL. Nice. Okay, so now we got a folder with the whole project here. So I'm going to move into that. And here's where all of our files are for running our API. And the first thing I'm going to do is open up my text editor. I like Sublime Text. You can use whichever text editor you like. That's what I like. So most of the code is in server.js, and I'm going to make this nice and big so everybody can see. And this is where all the code lies. We got a little config file where I have references to those ABIs and also contract addresses. And of course, we're connecting to the Ethereum network using Infura. And you need to be able to put your Ethereum project key in there. So I'm actually going to head over to Infura. I'm going to go over here, grab my project key, just do that project ID, and go over to my code and paste that in there. So this way we'd be able to access the Ethereum mainnet using Infura. So that is how we do that. I'm going to do something a little different in this example. I'm going to not access mainnet directly. I'm going to use Ganache CLI fork of mainnet. So basically it's like a little development copy version of the main Ethereum net on your local machine. So in order to do that, you'd have to install Ganache CLI, which I already have installed. So I'm going to show you the command is npm i-g Ganache-CLI. So if you have Node.js installed, you have npm, which is the package manager, and you'd be able to install a global package like Ganache CLI that way. So I'm not going to run it because I already have Ganache CLI. So to run Ganache CLI, you use the Ganache-CLI command, and I'm going to do some flags for that. So I'm going to do -f, which is for fork, and I'm going to grab this URL here. So I'm going to use Infura to copy the blockchain to my local host and have my own little development version. And for Ganache, it likes having a network ID, and I'm just going to do 999. Doesn't matter what number you put there, but it helps out Ganache CLI internally. And I'm going to run that. And that basically just takes the mainnet blockchain and uses Infura to grab it. And it creates a bunch of Ethereum wallets that have 100 test ETH in each of them. So this way I can do Ethereum operations using the address and the private keys. Totally not usable on the production blockchain. But what I'm going to do is I'm going to grab the first private key so I can do some write operations. I'm going to come over here, do that. So I got my wallet private key here. Usually you'd use an environment variable like this so you don't have anything important in your code that's you don't want it shown. It's a good practice to use environment variables. And instead of connecting with the direct Infura link, I'm going to do, instead I'll do HTTP //127.0.0.1:E545. So that way it is going to talk to my Ganache CLI instead. All right. So I hope everybody can see. I can actually make it full screen for you. Yeah, so the first thing we do is we are connecting to the C Ether contract, which is part of the Compound protocol, one of our many C token contracts. I'm just going to show you how to do ETH today. So in my config file, it's just a JSON file that has the mainnet C ETH address, also the ABI, and we create a contract object using Web3. So this way we can simply call the smart contract methods. I'm using Express.js, which is imported here. And you can create an app which will run a web server on your local machine. So on localhost port 3000, I'll be able to access my API. And these lines here are for parsing post bodies. I actually am not using any post requests, I believe, right? I'm just doing gets. Right. Yeah, so I don't actually need it, but it's good to have it in there in case you're making a full CRUD API where you have post requests with post bodies. The first route here is for grabbing your ETH balance within the protocol. Of course, when you first start out, it's 0 because you haven't put anything in the protocol. And what we're doing is we're calling the C Ether contract and doing balance of underlying, which is in the docs here. So if I do underlying balance, you can see here's the method. So when we do that, we're doing a call, which in Web3.js calls are get operations. They don't write anything to the blockchain. They don't cost any gas fees. So you're not going to be burning any gas to make these requests. And of course, the call operation returns a promise. So we can do .then. If you're comfortable with async await, you can also use async await. It doesn't make a difference. You could also do callbacks like Sean showed in his code. All works the same. But when we got the result, it is in way because in Solidity we don't really have decimals, so we got to do the full scaled up version. So we do balance of underlying, and we can send that to the client so they know how much they have in the protocol. And the next is a more generic method, which is just for getting the wallet balance. This one doesn't have to do with the Compound protocol. It's just seeing what your ETH balance is. This one is pretty easy. We got our ETH, our Web3 util method, because we import the private key to Web3. So we got our wallet sort of known within our Web3 object. So that one, again, also we send the balance of our wallet. And why don't I run through these so you can see them in real time? So the first thing I got to do with my my folder where I clone the project, this is where all my files are. I got to do npm install. And what that's going to do is going to install each of the dependencies in here. So we got Express.js and Web3.js, which are project dependencies. It's going to grab their libraries from npm and create this node modules folder real quick. So that's still running. Nice. Okay, that's done. So in order to run the API, we have to make sure we got our key, we got this. Okay, it should work now. So we do node server.js. Great. So we logged a line that says API server is running on port 3000, which if we go to the bottom here, that's where that line is. And I got some curls that I put in here to make it super simple. So we can get our wallet balance first by doing curl. And I'm going to actually make a new terminal window. Make that nice and big so people can see. And here's where we're just going to do basic HTTP requests to our running API, which is on localhost as well. So I'm going to paste this in curl localhost wallet balance ETH. And of course, we have 100. We have 100. It doesn't make a new line, so that's kind of hard to see, but we got 100 ETH in our test wallet, thanks to Ganache CLI. So that API endpoint works. Let's see what else we got. We got our C ETH as well. So we should have 0 C ETH because we haven't put anything in the protocol yet. So I'm going to grab that URL and do that. And of course we got a 0 here because we don't have C ETH. Nice. All right, so the next thing we want to do is, I'll check the protocol balance, which should be 0 as well. All right, yep, got 0. And next we want to actually do some interaction with the Compound protocol. We want to supply some Ether. So in order to do that, we need to call the cToken mint function, which we can see in the docs here. You could call it in Solidity or in Web3. And basically what you're doing is you're sending ETH from your wallet and you put in the amount of ETH you want to send, and that'll supply it to the protocol. And you get C tokens in return when you mint. So you're minting C tokens. So in this case, we're going to be minting C ETH. So how much should we supply? I'm going to go with 3 ETH. So we're going to grab the curl. Where is it? Yeah, the curl for supply. I have 9,000 here, but I don't actually have that much in the test wallet from Ganache CLI. So I'm actually going to do a little less. I'm going to do supply ETH. I'm going to do 3. So when I do that, it looks like I got bad request. supply ETH amount. Here's our route here. So if it's not a number, then we get that 400.
Adam, does that have something to do with that it's a GET request rather than a PUT, or does that matter?
No, that shouldn't matter. I have the URL parameter as our sort of way to carry information into the API. So yeah, we're using a GET. Not sure why it failed. Usually when you're live coding, that happens. Okay. Let's see. Oh. Missing network ID. Oh, interesting. So I think that's Ganache CLI having some issue. Let's see. Maybe I could try restarting Ganache CLI.
Everyone's seeing the real fun of blockchain coding here.
Yeah.
So state of the art. There's a
Yeah, let's run it again. Let's see what happens. I'm gonna do the same thing. Supply 3 ETH, bad request.
If you look in the questions here, someone thinks they might have found your curl, that you need a colon, perhaps in front of the supply ETH.
No, this is actually part of Express when you have did I forget a colon somewhere else? No. I think the issue has to do with Center's account only has 0. Oh, okay, because I ran Ganache CLI again, so I got actually a different wallet address. Each time you run Ganache CLI, you get a brand new mnemonic and you get a brand new bunch of wallets. So I'm going to copy the private key and I'm going to put it here again. So that's a different one. So now it should be different.
Adam, can you talk a bit about how you're using a forked version of the Ganache CLI to fork things?
Yeah, sure. So I don't want to use real ETH today. I just want to be doing localhost testing, just make sure my code works before I put it on the live internet. So you can grab a copy of the production blockchain using Ganache CLI, using that -f flag. So that basically takes a copy of the production mainnet blockchain and brings it to my localhost as a testing version with a little sandbox. And each of those accounts that I showed over here, these are test accounts and they have 100 fake ETH that only work on my localhost. So we got that going. Let's see if I can add supply assets now.
So it's really useful. So you don't have to deploy the compound contracts or anything like that. It's already there for you.
Exactly. Yes, the compound smart contracts are live on mainnet. If you head over to the docs and go to getting started, we can see the networks tab here. We got each of our addresses of each of the seed tokens and stuff like that. And I, of course, put that in my config.json, which is being imported into server. So that way we can access those directly when we're creating our Web3 objects. And it looks like it worked this time. We got an OK reply from the API. So that means we supplied some assets to the protocol. And of course, now that we've supplied some ETH, we supplied 3 ETH, we should get some CETH in return. So if we do wallet balance of CETH, we should see some CETH. And it's usually a bit off from 50-to-1 ratio. So yes, we have 149.9 CETH in our wallet now that we have supplied 3 ETH to the protocol. So if I get my wallet balance, it should be 97-ish because I supplied 3. I had 100 to start out with. So yes, we have 96.997. And of course, that little bit that because we don't have 97 exactly, the little bit is burned as gas. So when we send a transaction to the network, we burn some gas. And of course, if we check out our supply method, we're actually doing a send instead of a call like we would with the other ones. The send is for writing and call is for reading. So that's why we burn some gas. And
Adam, just a quick question. Because Solidity doesn't have like floating point integers, but in this case we are able to return decimals. Is that Web3.js or is that Ganache that is taking care of doing that for us, essentially doing the math to convert from Wei to ETH?
Yeah, so we have utilities in Web3.js, and we can actually do stuff like two-way or from Wei. So two-way will take a amount, like I put in 3 ETH earlier to supply. So it takes two-way, which will take my 3 and turn it into 3 with 18 zeros appended onto that. So that way, when we talk to Ethereum, it knows, okay, this is how much we'd have if we were able to do decimals. So it scaled up by 1 times 10 to the 18. And I don't think I have any references to from. Oh, I do. Okay, cool. So like when I do balance of underlying, I'm getting that amount with the 18 extra zeros in the end, and I'm able to convert it to something that's easier for us to read using the Web3 utils, two-way, from Wei. And of course, Wei is the basic unit. In case you want to use a fraction of an ETH, you'd use a Wei. So like 1 Wei is like all those zeros and then a 1. So that's like the smallest fraction of ETH we can have. All right, so now that we have supplied, we can check our protocol balance. We should have some ETH within the protocol. So if we check that, we've got a little bit less than 3, 29999. And now what we can do is we can wait Ethereum blocks, and each Ethereum block is about 15 seconds. And whenever someone interacts with the Compound protocol, interest accrues. So for each block that we wait, we earn the varying interest income. If you come over to compound.finance and you go over to markets, we can see the interest rates for each asset. So I supplied Ether, the supply APY, so how much you earn on Ether in a year is 0.01%. So each Ethereum block would get like a little tiny fraction of Ether. And of course, we can actually see that amount. If we go over to docs and we get there's a supply rate. Yes, so this will actually tell you how much ETH the protocol is adding to your adding to everyone's balance each block. So it's a actually small amount of ETH. So now that we have supplied some assets, they're getting some interest. We can pull our assets out of the protocol using the redeem function. So in our API, we got redeem. So we can redeem and we can say the C token amount. So for me, the amount of C tokens I have, we said it was like 150-ish. Yep. So I'm going to actually grab, I'm going to grab the whole amount. And I'm going to do redeem. So I'm going to take this. And we redeem with ETH. You can also redeem with CETH if you'd like. The C token contract can accept an amount in ETH or an amount in CETH. But for mine, let's see, we're using the redeem. So that is using the C token amount. Okay. So we do, let's see, do that amount. Let's see what happens. Okay, yeah, we got a 200 okay, which means that the transaction worked. So now we should have a wallet balance that is closer to, it should be like 99 point something because we did burn some ETH for gas. Yep, so it's 99.99. And of course, if you kept assets in the protocol for longer, this number would be above 100. But we kept it in for so short, and we also burned some for gas. And now if we check our C ETH balance, it should be 0. Right, it's 0 because we redeemed each of our C tokens. And our protocol balance, of course, will also be 0. Yep. Cool. So this is a cool way to have a layer on top of the Compound protocol to make REST API requests easy for, say, customers that are like want to integrate with your smart contracts and they don't know how to use Web3. They're like some kind of institution that does not have Web3 developers. They can use your REST API to do this sort of thing. So it makes it easy for them, makes your audience wider, your customer base wider. So yeah, that's this workshop. That's the content for building your own Ethereum API. Hope you all enjoyed it. I'm open to questions, can help you out.
Yeah, thanks so much, Adam, for this this excellent code walkthrough. And thank you, Sean, for sort of setting the table for it. We'll now open up to questions. We got Brennan, who you've heard. He's been in the chat collecting questions from everyone. Drop them in the Q&A. Coogan from ConsenSys Academy and the developer relations team. Coogan, what do we got in terms of questions?
Hi there. So this first one is going to be for Sean, but Adam can also weigh in. Jonathan wanted to know whether, Sean, whether you preferred Embark Subspace over Drizzle. And maybe, Sean, if you might be able to go into the differences briefly of Subspace and Drizzle and, what integrates best with Infura.
Yeah, so the Truffle Drizzle library and Subspace are both very similar in their purpose. Subspace, I think, has a bit, the pre-configured methods of Subspace, I think, are a bit better. And there's just it uses this thing called the observable model. And I think you should try both. You can just spend a few minutes playing around with both to understand them, but I'd recommend Subspace to start off with. Yeah, that's the summary. I can go talk on the community forum for more detail. Yeah,
that's great. Next question is for Adam. We're doing rapid fire here. Adam, there are a couple questions, one from Julian, another from Andrew, trying to understand like whether there's an official REST API available from Compound or whether the protocol itself is a smart contract. Would you be able to clear up that distinction between a proper REST API versus, let's say, the Compound protocol that you were sort of interacting against?
There we go. Yeah, so Compound does not actually have a REST API that you can use to access our smart contracts. You'd have to use Web3 in order to access them directly. And of course, this walkthrough is for spinning up your own REST API that will serve your consumer base directly. So yeah, there's no official REST API. You'd have to create your own, spin your own up.
Gotcha. And so this tutorial you just walked through was you spinning up a REST API to hit the Compound smart contract. Is that correct?
Right. And of course, I ran this on my local host, but you can spin it up on AWS, Google Cloud, whatever you'd like to have an official production API.
Fantastic. Amazing. This is a perennial question that comes up in all these. Web3 versus Ethers JS. We'll start with Sean. Sean, with Adam. Adam, do you have any preferences?
Of course, I like Web3, but the only reason I like it over Ethers is because I learned it first. I haven't taken a peek at Ethers JS yet, but I would love to dive in and see what's different about it and see if it's better for me. But yeah, really no particular reason.
Sean and I are collaborating on the definitive article, which is going to map everything for everyone. So look out for that in a little bit. But we sort of look at like just they're both basically. I think in a tutorial, use the one that the tutorial is using. So Adam's using Web3 here, like use Web3. But I think it just depends on what you're looking for. If you're looking for web performance, Ethers is a smaller library. So if you're really like, I need that extra little bit of advantage, it's good, depending on your feelings on documentation, downloads, projects using it. So we kind of we've outlined that. I don't know if you want to add some detail to that, Sean.
No, that's great. I think Ethers.js had a bit better documentation around it, a bit better testing within the language. I think for a time you'd see, I guess, like less error messages you didn't understand. I think Web3.js has caught up a bit, and Ethers.js has caught up to Web3's features. So I have a slight preference for Ethers, and that's my hot take on that.
That's fantastic. Got a question for Adam here, which will probably be one of our last ones. Is from Husney. He would like to know how the algorithm works for interest rates and how it is controlled in Compound. I know that's a kind of a technical, can get pretty deep pretty quick, but do you have a quick answer for that one, Adam?
Yeah. So there are smart contracts that are interest rate models for each of the C token assets. And you can actually have these changed if you don't like them. The protocol is now governed by the community. You can propose changes to the protocol, any sort of update, any sort of modification. You can create a code proposal that will be integrated into the protocol, and you can vote to have it changed if you don't like the interest rate model. So community governance was released recently in the past few months, and we've already seen some interest rate changes that were proposed by community members. And of course, you can go over to compound.finance/docs, and you can see the addresses of our interest rate model smart contracts. And they will show, based on the amount of assets that are supplied, how much are being borrowed at one time, how much, that sort of thing, that will show what the interest rates are for suppliers and borrowers at any given time, just based on that sort of stuff. It's good for math people, economics people that like that sort of thing. And also we have a page on a website called Observable, and it has a nice little sort of slider for you to see what the amount of the interest rates are at a certain protocol weight, how much is supplied, how much is borrowed. I believe the link to that observable page is in the docs. You can find it there, or also you can come over to our Discord, compound.finance/Discord. We have links there and people that can help you out and show you that sort of thing. But yeah, it's definitely interesting topic, economics. If you're interested in that's how it works. But yeah, it's a smart contract for each individual C token.
Adam, I have a question for you. I guess the topic to bring up. So the Compound, it'd be great to have people build on top of it. I think you guys, Compound's fully supporting that, and it'd be awesome to see. Could we maybe generalize it a bit? Maybe if you screen share your code just one more time, and how would you generalize that API to someone's, maybe the maker contracts or someone deployed their own contracts? Can you quickly walk through the steps of how someone would generalize it to their own needs?
Yeah, great question. I'll do the screen share, desktop. Okay, cool. Everybody see? Yeah, so what I did was I actually grabbed the smart contract addresses and the ABIs from the Compound website, and I put them in this config.json file. So here's the mainnet address for Ether contract, and here's its ABI. So you can do this for any contract that's deployed on the Ethereum network. So if I wanted to do that for, say, a Maker contract, I could go over to MakerDAO's website, look at their release notes, and I'll be able to see their contract addresses. So I'm just going to grab this one for our sake. And what I could do is I could go to etherscan.io. I can paste in the address, and it comes up with the contract. And if the contract is verified, like companies like Compound verify the deployed contracts, MakerDAO, I'm sure, does the same thing. You can actually get the ABI as well. So if you have the address, you can grab the API, copy it to your clipboard, and you can paste it in here like that. So that way you can have a different smart contract, and you grab the address, the ABI, and of course with Web3.js, we have the contract constructor. So we can create an object that's able to reference those. And so we pass in the ABI, the address. So you could do this for any smart contract. And then immediately you're able to start calling the methods that smart contract provides. So like balance of underlying for MakerDAO, you do MakerDAO sort of methods like minting DAI and stuff. So yeah.
Perfect. Thanks so much. And I'll hand it back over to Tom to round us up.
Perfect. Thanks, Coogan. I just want to really say thank you to Sean and Adam. This was awesome. We love, having sessions like these where we can get into the code on screen, ask questions, do some live debugging with friends, which is always a fun thing to do. And graciously, Adam's offered to actually come back for another one of our bi-weekly live streams to do a session on governance. So once we nail down the date on that, we'll announce it. We'll definitely be back in 2 weeks with another webinar. We might also have some additional webinars that fill in some of the off weeks in June with some special content. So just look out for those. And then, of course, the most often asked question, is there a recording? We are recording this. So we will get it to everyone via email within a week. And so if you want to rewatch and follow along with Adam's article, which Coogan posted in the chat, and all the documentation, you can do that. So that will all be coming to you via the email that you signed up for this. We see that there's still questions coming in, so we're capturing those, and we'll do our best to follow up with those and sort of route those to Adam, Sean, and our team so that we can get you answers and help you out, so you can drop those in. But just want to, again, thank you, Adam. Thank you, Sean. Thank you, Coogan. This is a great session, and hopefully see everyone back here in 2 weeks for our continuing series. So before we go, we'll start with Adam first. Anything you want to, this is shill time, anything you want to promote, anything that you want people to go to, see, do?
Yeah, sure. Head over to the Compound Discord. We can help you out with your Ethereum projects, talk about any other questions you have. I see there's some more questions that we didn't get to, but yeah, you can come over to the Discord. We'll help you out. I'm there. I'll answer your questions. Definitely help you debug stuff. Yeah, happy to be here. Thank you so much for the opportunity.
Cool. And Sean, anything you want to promote, push people towards?
Yeah, thanks for listening, everyone. Yeah, if you haven't created an Infura account yet, it's really easy to check it out. Just register and try playing around with the tutorial that you saw today. We have a community site, and yeah, we're very free. And if you have any questions, please talk to us there.
Cool.
Thank you all.
And I'll just wrap it up with saying, if you're trying to learn some of the fundamentals, there's things that were covered here that were sort of maybe a little faster than you could get to. Learn.consensys.net is where you can find all the free ConsenSys Academy offerings. So that will get you up to speed. And a copy of this recording will also eventually be posted there as well. So thank you all. It's been great, and see everyone in 2 Thursdays.